Hello everyone, welcome back to my class today. In today's video we are going to discuss something about the beautiful colors of fruits and vegetables that we see every day in our plates. Have you ever wondered why spinach is green, carrots are orange and beetroot is deep red in color? It's all because of the pigments present in the fruits and vegetables. These pigments are not only color appealing and tempting, but also it possesses the nutritional value. These are the bioactive components. So in this video we are going to discuss about the pigments, classification of pigments that are based on their solubility, their chemical structure, and what happens when these pigments are being treated with heat while cooking. So let's get into the video. Introduction. So these pigments are naturally occurring substances responsible for the colors in the fruits and vegetables. So these pigments makes the fruits and vegetables more colorful. So these color influences the sensory quality, acceptability and nutritional value. The sensory quality. So naturally we attempt to the taste, the eye appeal, the appearance, that all comprises under the sensory quality. So it is getting improved in the fruits and vegetables because of the pigments. And nutritional value, apart from the nutritional value also, the pigments possesses some antioxidant and anti-inflammatory activities that makes it ideally important for maintaining the health. So pigments are classified based on the solubility as fat soluble and water soluble pigments. So here is the classification. The water soluble pigments are betalins and flavonoids, and the fat soluble pigments are carotenoids and chlorophylls. So here we'll discuss one by one pigments in the upcoming slides. So the fat soluble and water soluble pigments, what is the difference? What is a fat soluble pigments? So these pigments are insoluble in water. As you know, water is the universal solvent. These pigments are not soluble in water. These are soluble only in fat and the organic solvents. These fat solvent substances like ether, petroleum ether, ethanol, in like those substances only these fat soluble pigments will dissolve, similarly to the fat. So alternatively, here in water soluble pigments are soluble in water. So location, these fat soluble pigments are located in the chloroplast and chromoplast of the cells, plant cells. In the plant cells, chloroplast, the chlorophyll pigments are there. In the chromoplast, the other carotenoid kind of pigments are located. At the same time, the water soluble pigments are present in the cell vacuoles. So it is easy to so it will easily, readily get soluble and leached out in the water during the process of cooking. So here these components are very stable to pH changes, either it is acidic or alkaline pH, or while heating also these pigments, those are present in the chloroplast and chromoplast, will not leave the food that easily, like unlike the water soluble pigments. So the absorption in the intestine, the absorption of fat soluble pigments requires fat. Here these water soluble pigments are very sensitive to pH, heat and light. So these factors can easily damage the water soluble pigments. So the first fat soluble pigment is chlorophyll. Chlorophyll is a green pigment present in the leafy vegetables. These pigments are very essential for the photosynthesis. These are fat soluble in nature. The structure of chlorophyll is, it contains a porphyrin ring. Porphyrin ring is the ring-like structure which magnesium atom at the center. The right side picture shows the chlorophyll A and B structure, and it also has the long phytol side chain. So this makes the compound a fat soluble. So the chlorophyll is also classified into chlorophyll A and chlorophyll B. So the molecular formula for chlorophyll A is C55H72 magnesium atom and N4 and oxygen 5. So in chlorophyll B, the molecular formula is C55H70 MgNO6. So this is the only difference between the chlorophyll A and B pigments. So next one is carotenoid pigments. These are yellow, orange and red color pigments. These are also fat soluble hydrocarbons. The hydrocarbons is the term we use for the components which contains only carbon and hydrogen. So it doesn't contain oxygen atoms. So these are mainly, for carotenoids are mainly the fat soluble hydrocarbons. These compounds acts as a powerful antioxidants. For example, the beta carotene, vitamin A in human body acts as a powerful antioxidant. Vitamin A is derived from the beta carotene in the human body. So some have the provitamin A activity, that is what I am saying. The beta carotene is the identified from the plant sources, but in the human body the beta carotene gets converted into vitamin A. So we call the carotenoid substances as a provitamin A. So in the types of carotenoids, carotenoids are also of two types, the carotenoids, carotenes or xanthophylls. The hydrocarbon carotenoids, the carotenoid substances which contains only carbon and hydrogen atoms, or hydrocarbon carotenoids, and xanthophylls contains the oxygen atoms. So these are long conjugated polyene chains. These are like some chain like chemical structure. So these are derived from the isoprene units. Isoprene units, some plant steroid like substances are produced through the mechanism called melvanate pathway. So in the melvanate pathway only we will be getting the isoprene units. So these comes under the isoprenoid categories of nutraceuticals also. So the molecular formula for beta carotene is C40 and H56, whereas the xanthophylls contains either hydroxyl groups or double bond O groups, like a keto group or hydroxyl groups in their chemical structure. So the next one is an anthocyanins. Anthocyanins is a water soluble pigment. So those first two pigments we have seen, right? The chlorophyll and the carotenoids are fat soluble pigments. So all the other pigments are water soluble pigments. So in the anthocyanins, these pigments are responsible for the red, purple, blue colors in the fruits and vegetables. So these categories belongs to the flavonoid family, flavonoid group. The color changes with the pH. So the color often changes with the changes in the pH. So the chemical structure contains the flavinium ion structure. So anthocyanidins, so we are discussing about anthocyanins, but anthocyanidins contains the flavinin ion ring structure. So which contains 3 rings, 2 benzene rings and 1 interconnecting heterocyclic ring. So this is the flavinium ion structure. So anthocyanidins is a flavinium ion structure. So anthocyanins are glycosides of anthocyanidins. So which contains one more glycoside bonds and other sugar group attached to the anthocyanidins. So it also contains the phenolic rings. Phenolic ring structures are present in these chemical structure. So in these glycosides and the sugar molecule attached to these anthocyanins makes it more water soluble. So that is a major reason all these water soluble pigments contains, most of the pigments contains the glycosides. The glycosides are responsible for the water solubility. It determines the water solubility. So next one is the anthoxanthins. These anthocyanins are red, purple and blue pigments, whereas the anthoxanthins are white to pale yellow pigments. These includes flavones and flavonols. Flavones contains the flavonols contains the OH groups like alcohol groups in it. So these are less intense in color. These are polyphenolic components. The polyphenolic components makes it more makes it a very powerful antioxidant. So the basic flavone structure contains C6, C3 and C6 ring-like structures. So these are also often present as a glycosides. So the glycosides makes the component water soluble. So the next component is betalins. These are nitrogen containing pigments. These pigments only contains the nitrogen atoms in it. So these are found very limited in the plant families. So these don't coexist with anthocyanins, which is also a red pigment. But these pigments are different, which contains the nitrogen atoms in it. So these are derived from the beta-limic acid. The betalins are also classified as beta-cyanins, red-violet and beta-xanthins, which are yellow in color. So in the right side picture is a beta-in. These also comes under the classification of beta-cyanins. In the structure you can see the nitrogen atoms attached to the rings. So the food sources. The food sources of these water soluble and fat soluble pigments are given as follows. The chlorophyll is present in the spinach, amaranth leaves, all the green leafy vegetables, broccoli, green peas and beans. And in fruit sources it is present in the raw mango, kiwi, green apple and gooseberry. So the carotenoids, which includes beta carotene, lycopene, lutein, zeaxanthin, cryptoxanthin, and all those carotenoid classes are present majoritarily in carrot, pumpkin, sweet potatoes, tomatoes, spinach, kale, yellow maize. And in fruit sources, it is present in mango, papaya, watermelon, orange, and apricots. So anthocyanins, the red cabbage, purple carrot, purple brinjal, red onion, these reddish purple vegetables contains anthocyanins. And grapes, jamun fruit, berries, blueberries, and varieties of blueberries, and pomegranate, plum, these contains anthocyanins. Also in the cauliflower, onion, potato, and cabbage, these are colorless vegetables. The color intense ranges from pale white to a light yellowish. Contains the anthoxanthins. Apple, banana, and pear also contains anthoxanthins. So the betalins are present mainly in the beetroot, amaranth stem, and Swiss chard, and in prickly pear betalins are also seen. So its food sources are very limited, as we have discussed earlier. So the importance, the food pigments improves the visual appeal to the foods. It increases, it gives the visual appeal. So it is very attractive when while we eat because of the food pigments. So it also provides an antioxidant activity, contributes to the health benefits, and these food pigments indicates the freshness of the fruits and vegetables. So in the health benefits, chlorophyll is a detoxifying agent. It binds a carcinogen and in the digestive tract. It acts as a detoxifying agent, binds with carcinogenic substances and removes it from the human body. It supports the liver function and wound healing processes also. It also exhibits antioxidant properties and anti-carcinogenic effects. So the carotenoids, the next one is carotenoids is a very large group of substances. So these are strong antioxidants. It protects the cells from oxidative damage. So the oxidative damages are caused by the free radicals which are generated from the pollution and other causes like respiratory burst and all those reasons in the human body. These free radicals damage the cells. The carotenoids possess the antioxidant activity which neutralizes the free radicals and protects the human cells. So generally we say the fruits and vegetables protects the human body. So all those protective factors are not only because of the vitamins and minerals but also because of the pigments which has the anti-inflammatory and antioxidant properties, which by that these pigments protects the human body. So the beta carotene acts as a provitamin A. So it's a provitamin A in the human body. It is converted into vitamin A and it supports the vision, immunity, and epithelial cell health. So lycopene is one important carotenoid substances which helps to reduce the incidence of cancer to a greater extent. So lycopene is responsible for preventing cancer. So lutein and zeaxanthin protects the eye health and prevent aging related molecular degeneration. So aging related molecular degeneration includes the development of cataract, eye health, and all those. So these and all will not develop if we continuously eat the pigment rich fruits and vegetables. So next one is anthocyanins. These improves the cardiovascular health by reducing the oxidative stress. So anti-inflammatory properties it has, and also the anti-cancer activities. So it supports the cognitive function and glucose regulation. So these anthocyanin pigments is responsible for the glucose regulation also. So thereby it supports the pancreatic health and cognitive function, and all those are because of the anthocyanins. The anthocyanins for remembering, I am telling you, these are purple red color vegetables and fruits. So anthoxanthins are also the antioxidant activity and the capillary strengthening effect it will possess. So and also it helps in reducing the inflammation and chronic disease risk. Chronic disease risk is mainly because of the inflammation caused in the human body. For example, the vascular inflammations leads to cardiovascular diseases. The inflammations in the body, in the pancreas only leads to diabetes. These are all chronic diseases. So it will protect against the chronic disease risk. So betalins, these are potent antioxidants with hepatoprotective effects. These betalins protects the liver health, protects the liver from damages and These have detoxification effects, right? So these detoxification protects the liver. So liver plays a major role in detoxification mechanism. So these betalains are also play a very essential role in the detoxification. It also improves the blood flow as it contains nitrates, nitrogen substances in the betalains. It improves the blood flow, endurance, and reduce inflammation. So next one is what changes it will undergo while we introduce heat or pH changes, while we cook with other substances and all. So heat and acidic conditions removes the magnesium from the chlorophyll and converts the chlorophyll into a dull olive color. So while cooking the green leafy vegetables, it will turn into a light olive colored things. This is because of the removal of magnesium ion from the chlorophyll due to heat and acidic conditions. So alkali conditions retains the green color but destroys the vitamins and softens the texture. So in alkalic conditions, like while we add salt during the cooking process, the green color will be retained, but sometimes the vitamins are destroyed. So carotenoids, these are very heat stable. So mostly these fat soluble pigments are very heat stable. Because these are water soluble pigments will leach out, the fat soluble vitamins won't leach out in the water. So these are mainly stable. So in the cooking, during cooking, it breaks the cell walls and increases the bioavailability. So cooking of carotenoids increases the utilization in the human body. So the excessive heat and oxygen cause the oxidation and color fading to happen. So as these are fat soluble and it is readily it is a powerful antioxidant, so the oxidative damages because from the environment causes the carotenoid substances to fade its color. So the presence of fat enhances its absorption. So for absorption in the human intestine, these fat is essential for carotenoids. And anthocyanins, these are sensitive to pH. So either the acidic pH or alkaline pH will cause damage to the anthocyanins. In acidic medium, red color is retained. In alkaline medium, blue, green color, and blue or green color it will change and degradation happens. So water cooking causes leaching and color loss. While cooking with water, the content the coloring substances, the coloring pigments, anthocyanins present in the fruits and vegetables will move out in the water and thereby the color loss. For example, while making the vegetable soups and all, you will be able to see the color is leached out in the soup water and leading to the boiled, cooked, colorless vegetable, some pale colored vegetables. That means the pigments are moving from the food substances into the water. The next one is anthoxanthin. These are sensitive to alkaline conditions. Yellowing or browning happens. Acidic conditions helps to maintain the color. So and then yellowing or browning. So anthoxanthins are present in potatoes, cauliflowers, and all those. So in alkaline environment, these browning reactions happens. In acidic environment, we are able to maintain the color and the anthoxanthin pigments. Betalains, these are sensitive to prolonged heat and light. It's stable between the pH 3 to 7. That is in the acidic pH it is stable, and once the pH is crossing the 7, means alkaline pH, it will lose its color. The color fades with overcooking but less leaching than the anthocyanins. Anthocyanins we are able to see lots of leaching, lots of moving out, and the pigments will move out into the water. Even for example, the Indian berries, the Indian berries, if we eat, we'll able to, your tongue will turn into a red color. It is because of the anthocyanins pigments. So this is the summary of the pigments, its solubility, its food sources, and the changes happening during the cooking and the health benefits. These are my references. Thank you.